Since the invention of the first electronic computer, which fueled what's become a truly radical technological revolution, the world people once knew progressed into this fast technology and data-driven one we know and live in today. Consider that what was once an enormous calculating machine that took up an entire room, and a large room at that, can be found in your pockets today and is immensely more powerful. Still, no matter what head-spinning progress we've made in technology, there are still some challenges that the computers we use today simply can't seem to overcome. The computer industry is laser focused on finding a solution, an even more revolutionary one, and some even firmly believe that quantum computing just might be it. Okay, so the computers we use today store information by using binary digits, bits or noughts and ones as they're known, and they process that information by using simple logic operations. In order to do these functions, standard computers use switching units or transistors. Since the invention of the first electronic computer, the computer industry has been successfully dealing with this by making transistors smaller and smaller. Now there are billions of transistors, each close to the size of an atom, placed on a microprocessor with the purpose of making the computer able to store and process more and more data. And as impressive as this may sound, and it is, the transistor is still a switch. It can either be on or off, either 0 or 1, and that limits its potential. No matter how many billions of transistors exist in a conventional computer, when faced with a more complicated operation, the computer will take more and more time and more energy to solve it, as the transistors can only focus on one thing at a time. Enter quantum computing. So, what is quantum computing, and how can it solve these challenges? Well, the idea for creating a quantum computer can be found in quantum mechanics. Quantum mechanics is a physics field that studies how everything works at atomic and subatomic scales. But at such a small scale, according to quantum theory, the laws of physics we know on a macroscopic level don't seem to apply. Quantum theory suggests that at atomic and subatomic levels, particles can actually be two different things or in two different states at the very same time. Applied in computing, this would result in quantum computers that, unlike the binary language of bits 0 and 1, the regular computer parlance, they would use quantum bits or qubits. Qubits can be in both states at the same time. This is known as a superposition. They could be a 1 or a 0 or both 1 and 0 at the same time, which would enable quantum computers to store and process incredibly large amounts of data while using much less energy than conventional computers. So, much like the wave-particle duality suggests, according to many physicists, the qubits could exist in different states at the same time. The computer industry races to find a way to use superposition and entanglement to make qubits. The next challenge here is to actually control them, which in the quantum realm may sound close to impossible since nothing is as we know it. And if they manage to do this, they may make a quantum computer with far more power for processing. And this, while years and years away, according to many scientists, may certainly revolutionize our world. And just like at the beginnings of the computer era, where people couldn't quite anticipate how crucial a role computers and technologies would play in our lives, we can't really predict the exact outcome of quantum computers and their influence on the world. However, seeing how impactful and truly life-altering standard computers have been for us so far, operating on just two simple choices, one can only imagine what quantum computing with qubits executing thousands and thousands of operations at the same time can do. Let's just hope we have transcended enough to challenge the corporations before they wield such power. We could enter a realm of undreamt possibilities with such power, but at what cost? Be careful what you wish for. I'm the OBG.